welcome to this talk, Calibrating Type, with David Berlow, Dave Crossland, Lasse and Santiago Orozco. And I hope they will talk about different perspectives on variable fonts, about font producers, app developers, and font users, and hopefully speculate about different scenarios ahead. So please start.
All right, everyone. So yeah, I'll start presenting. Oops, let's go back to the first slide. All right. So yeah, welcome to our presentation today. So I'm Dave Crossland, and I'm presenting with David Berlow, Santiago Orozco, and Lasse about the topic of calibrating type. And we have been working the last few years, David, Santiago, and I on a number of fonts, including Roberto Flex and Amstelvar, and we've wanted to see variations technology, realize better typography, and so that can only really start with variations technology. And many gains have been made, from compression to animation, smooth typographic text changes with weight and width, and also optical size. Many variable fonts have been published in the last 5 years. And yet, we're not really seeing the full application, the full realization of these fonts, even on the web. And so in today's presentation, we're asking why and how to move forwards. So I like to say there are three main benefits to variable fonts: to compress, to express, and to finesse. And that first benefit, to compress, is what's really driven the first implementations of the technology. The file size savings that you can obtain when you're merely reproducing the same fonts and typography that you could do before. And this sort of introduction of a new medium that mimics the previous one is something which Marshall McLuhan has described, something that kind of always happens when you introduce a new medium. But that then gives way to a new way of thinking about the new medium. And so in those other two benefits, the expression and the fine-tuning of typography, then I think that's where we see this potential for doing things in a new way. And that phrase, the new typography, that's a famous phrase in the history of type. And now, in addition to the typefaces themselves, another essential feature for implementations is providing the sufficient information needed about the context the type is rendered in, so that the type can be correctly calibrated. This idea of correctly calibrating the type is important. And for branding, variable fonts offer the new possibility of optical sizing. And so we've seen that in a lot of branding in different sectors, technology, fashion, and others, there's been a move from high stroke contrast typefaces towards low stroke contrast typeface designs. And this has led to a kind of homogeneity, what's been called blanding. And so moving forwards, optical size variations can help with this, but only if you know what size you have. And so for documents, on the other hand, the sort of similar issues, responsive design is somewhat brittle. So having different sets of viewport designs and toggling between them means that the quality of your typography is deteriorating when you're at the edges of those designs and only some of the attributes of your type can flex. So the newer intrinsic and fluid approaches to typography can provide consistently high quality layouts when they're using typefaces that can respond fluidly and fully. And so that's what we've been investigating. We've been developing typefaces that can do that, and we've now been working on examples of how to make this fluidity realized in the web. So I'm going to hand over to Santiago to talk about the type, and then he's going to hand over to Lasse to talk about the web page demos, and I'll stop sharing my screen.
Thank you, everyone. My name is Santiago Orozco. I'm a type designer and engineer for ATypI Home Bureau, and I'm from Monterrey, Mexico. That is pretty hot. Today we will have 38 degrees. That's 100 Celsius. So before I melt, I want to talk about one project that we've been working on that is called Roberto Flex, which is a variable font that has weight, width, optical size, grade, and parametric. Those are a lot of axes. So before we start, I would like to talk about a little bit about design spaces. So when we imagine a design space, we think of usually this shape. Like we have width, weight, and optical size, and this kind of design have been around since forever, and we only been playing inside that design space. But with this was also the multiple master model. From multiple master to variable fonts, the design space of variable fonts looks like this. It's a star, and with combining each one of these extremes, we make shapes like this. So with optical sizes of this Roberto Flex, it's designed specifically for 14 points, and this is the default that in variable fonts it's the center of the whole design space. So everything starts from here. So starting with the optical size for 14 points, we can see the main design feature that it has a generous X height, low ascenders and descenders. If we go down to optical size 8, we can see the difference that the X height is more generous. And if we go up to optical size maximum, it goes way down the X height. So with these three main optical sizes combined with all the other axes, we made 27 masters. That makes the register axis for variable fonts. And I'm always marking the center of it. See Roberto Flex, that's the center of all that. And combine it with optical size, we can see on the left the optical size 8, on the right the optical size maximum. And each one of these sizes and weighted have been calibrated for the specific sizes. So, for example, for optical size 8, the heaviest weight are not as heavy as the display sizes. And for the lighter weights, that lighter than this at 8 points, the type suffer. And that's not the case for the optical size for 144. That if it doesn't look, if it breaks, it's exactly because of this. This size is designed specifically for 144 points, and it's not being shown here at that size. So with this huge design space, 27 master, each one of those has a chart set for Latin, Greek, and Cyrillic. That, of course, it's a lot of, it's a team effort to make all these design space with all these many glyphs, and it was made by a team of people. David Berlow now made the Latin, Irene Blahu made the Greek, and I hope to pronounce this correctly, Cyrillic by Ilya Rudermana, Yuri Ostromensky, and Misha Strukova. So I hope that was okay. So yeah, it's a lot of work only for the register axis. So we have a variable font with optical sizes that go from 8 to 144 points with specific weight for each optical size, and the width axis that allows you to control the page with fluidity. And with this new grade axis that is being used in print media since forever. And some other special access for design-specific variations. So how does it look? As you can see in this sample, we can have a variety of weights and widths on the page. And if you ever design a newspaper or magazine, you will often find where there's a specification of space that you have too many words to write the article. And it's always a problem when you have more words or less words. So with the width axis, you can fit more words per line. And in the newspaper, sometimes the headlines look like this, like, there's some space and the editors ask you, we have to add exact 2 lines for headlines. So with this variable font, with all these options, you can make anything fit as you need or as the publication need. And this is how it looks in black and white. It is really very, very flexible variable font. But this special axis that I want to focus on is called grades. That if you are familiar with the term, the graded font were used in print media for newspapers because they use fast printing on cheap paper, and so when they printed, the ink spread a lot. So sometimes they needed lighter weights so the text doesn't look very dark on paper. So this is the lighter grade and the boldest. The 2 overlap look like this, and in making grades, it's very different from actually making weights, because when you're making grades, you don't want the page to reflow. You need to keep it the same amount of length of the text, just lighter and bolder. And in making these grade fonts, you have to have some considerations, like starting with the stems, they have to grow proportionally, and restricted by the proportion of the letter. So you have to make, for example, the letter E bolder, but without making it wider, because it will look wider and it will affect all the other letters around, and you have to they are very tricky. The rounds should grow proportionally in the whole system. As you can see, it grows the same inside and outside. And one important feature is the diagonals, that they have to remain the same angle. For example, when we're making the lighter weights, we tend to change the angle of the legs a little bit. But with grading, you need to keep the same texture of the text, just lighter and bolder. And so how does it work? Here's the default. And if we go to lighter, you can see the difference. Back when I was designing a newspaper, launched a new newspaper in Mexico, Reporte Índigo, and the first number of that publication, we used one type, and the first number were too heavy, were too dark, and the editors request us to make a lighter weight, so we made it. This is one example of that you make lighter or bolder without reflowing the page, with all this consideration of making grades. And on black and white, you can see the difference, bolder and lighter. And this, of course, is made for the whole space. As I mentioned, we have our design space, optical size, and with the variable fonts, because it's a star, the grade axis affects the whole space. So you don't have only grade for text sizes. You have for any size you want, not only limited to space. This is I always mention this because this is how variable fonts are inside. It's a star, and we make shapes sort of that. So with this variable font with grades, that designed for every optical sizes, that can help a lot for UI and text. And I think that the grades have been helping the print media for so long, and now everything is digital, and so I think that will be a great to have grades. So yes, this is the project. You can look it up on GitHub. You can follow me and all the other people in the team, and yeah, that's all I have. Thank you. And we are going to with Lasse that he will show some implementation of all these axes.
So what I did is actually typography in the browser with these fantastic fonts, and I implemented some nice layout things and typographic things that I'm going to show in a live demo in just some seconds. So one thing I'm going to show is fluid portal to portal, which is like responsive design, and how we decide to make columns, justifications, grade, and then also how these fonts can be used to synthesize glyphs when you need them. You'll see that in a second. There is a demo, and it would be ideal if any of you can spare some screen real estate to go to the demo and click along. Because one big problem with these things is when they go through video from my computer to your computer, you don't get like the original type that we want to show you actually. So best would be to visit that page and maybe just see what I do and click along and see how these things work. So let me just skip. What I did is I started from the original Wikipedia page about typography and stripped off a lot of unneeded stuff like JavaScript that I don't want to run, and CSS that we don't need, and that is maybe not even relevant for this page. And then I started to implement some own CSS framework that uses heavily CSS custom properties, or CSS variables, how they are called. And also I used Roberto Flex, which we just have seen in Santiago's presentation, and Amstelvar as new fonts for this page. So let me just see. This is basically what you get with the new fonts and the new CSS. And I have some helper scripts like widgets here, which can help me to demonstrate some things. So I want to demonstrate here. We can have different portals. This is not mobile optimized, so let me not go to this small size. So there is an algorithm that decides on the available screen space and the font size used, how many columns to display and how long these columns are. And the more, like, what we are trying to do is to not have too long lines here, so that the wider the screen gets, and depending on the font size, of course, we get a different amount of columns. So this is just one column, and around 1000 we get two columns. The widest columns in 1 and 2 column layout are 65 characters around, and in 3 column layout, which is around here, we get up to 50 characters per line, and in 4 columns we are down to 40 characters per line, which is to optimize the reading experience. these things. Also, the line space is adjusted depending on the column size. So going back to 1000, you might see that the line space is a bit more. That said, the next thing that was implemented, I got to change the widget now. There's an in-page widget, which is here, the demo control center. I implemented a justification algorithm because what the browsers by default provide in CSS is not doing it for us. We just can run this now. Which is interesting here. You can see like all the justification options are actually turned off. So this is only, this is only just detecting lines, which is not really easy in browser technology, and makes them accessible for us in CSS. So now we can add CSS for each of these lines and start to justify them ourselves. This is done on the lowest level of the DOM tree. It's wrapping the text nodes. So this is not changing the semantic map of the page at all. So we can use this, and stuff like screen readers and everything else should just keep on working, actually. What we also see is the analysis of the available space. So the more red you see, the worse the line is, the more you have to do in justification. So can just run maybe this, which is only using word spacing. This is what a browser would do. This is the same algorithm as the original text justification in the browsers, and you see all those rivers. You can also turn off these color coding. Just yeah, this is what you get in the browser. Like this, I made this justification, but the browser would do the same thing. But now it's more interesting that we can use actually the X transparency and letter spacing, and I'm not going to use word spacing in now, of the font. And the X transparency is the variable font specialty that these fonts provide for us to make text justification. To restart this here. And now we see how these columns justify just pretty nicely. It's also like this animation is also a nice hint for us to see that it's not yet the fastest thing on earth. It's pretty quick for 1-column layouts, and it's okay-ish for 2-column layouts, but actually for 3 or 4-column layouts, it's really slow. Oh, this is, by the way, this is not fully justified. So this is more like a soft rag write justification, because I did not turn on the word spacing. So if I turn on the color coding again, we get hints where we did not fully justify the line. So just looking like this line with word spacing would have big gaps in here because it's so bad. The line breaking and the hyphenation is from the browser. So that's something I did not implement. It's just taking whatever the browser gives us here, and then on top of that, do whatever we can with X transparency and a bit of letter spacing. So because it's so slow with nothing here. Because it's so slow with 3 and 4 columns, I just prepared these and ran these layouts in like beforehand, so you can just see how these pages look. I just want to give you an impression what can be done. These are fully justified. There we see also word spaces used, but also X transparency and letter spacing was used. And this is the full 4-column layout, how it comes out when we do this. Just for completeness, let me show you the color coding again. So this is how the analysis of the page looks, and immediately the bad lines that we get from the browser spring to our attention. Oops, didn't mean to do this. So that's a justification thing. Because one column layouts justify much quicker, I'm slightly positive that the performance of this thing can be improved when we convince the browser that it has not to consider line breaking and stuff like that when we ask it for the length of the actual line. So I'm turning this off. I'm pausing this because it's just taking too long now. The next thing I want to show is dark mode, and with dark mode grades. So I implemented dark mode in here, which is mainly just inverting all of the page and then undoing some of the color inversion to make it look okay-ish. The justification is still there. The most important thing about dark mode is that we can use grade in here to influence the brightness of the type, and it's been used for both for Roberto and for Amstelvár. The algorithm for grade is different for each font, and then it takes into, like, it has different lookup tables basically, and then it takes into account font size and font weight to find an ideal grade change in dark mode for these fonts. And one interesting thing is here in Chromium, like what we are looking at right at the moment, can implement the whole thing using pure CSS. Just what is required is the at keyframe animations, which can be used in a way like a lookup table function that also interpolates for us. And then at properties must be available. That's why it's only working in Chrome, because then you can interpolate custom properties in CSS. And it uses some more CSS math, like the CSS calc function, to do some more like easy interpolation. But the problem is the effect is very subtle, and we it's over video, and for this demo it's very hard to see. That's why I can turn it off, and it's probably not going to spring out a lot. So I implemented this amplify grade. Let's turn it on again. Slider, which just amplifies the effect so that that you all can see like a grade change when I activate it or don't activate it. So again, changing the grade in the font variation settings is all, the calculation is all done in CSS in this case. And you can see, I hope you can see how this gets brighter or less bright. This could even actually be a user setting so that the user can say, oh, this page is too bright for me, or maybe not bright enough. And then the user could dial in their preferences. So, and with that, the last thing I wanted to show is type synthesis, which we did in on this page for the superscript. Actually, it's very similar to what we did with grade. It also works entirely with at keyframes. And at properties, it takes in as main information the font size and the font weight, and changes the size, changes the optical sizes, depending on the surrounding type, and then displays this. And that's a nice way how we can create really optimized superscripts. It's in good hands.
Thank you guys so much for those presentations. It was really helpful to me to see them from the same context as the audience does, because I'm not used to being in the audience, but it was great to be in the audience and watch that stuff. So I want to give you the idea that we're showing very specific, we're working on very specific things, but we're working very broadly along these lines, looking at everything from the basics of the font tools to, what CSS has to be able to do more reasonably that it's not doing right now. And we're not just thinking about Latin, we're thinking about world scripts, working with 6 or 7 different scripts at the same time, sometimes 15 scripts at the same time. We're working with different browsers and different operating systems and different classes of type and different structures that people have for their variable fonts, and really, making this as inclusive as it is from the beginning in 2016, when we published our guide that is really calling for all the scripts to be starting to look at how the internal white space vertically and horizontally is related to the typography that you have, and which parts of typography different scripts are using, and how open type layout affects these things, is all one huge stew that's really taking a lot of different people's efforts to get to the point where it's commonly available and mostly under the hood, so to speak, in English, which means that most users just get the benefits, and they don't need to do anything. They can look up various functions and pieces of code that they can copy and paste into the fonts that they use. If they have the same variable axes, they can hook right into theirs. If their value systems are a little bit different, they can tweak the algorithms. If they want to use width instead of XTRA, they can use that. There's a lot of different options that we're exploring because the spec hasn't broadened since it was announced. We haven't gotten any sort of movement on advancing the specification to be more calibratable. And in case you don't know this, OS2 and values are very difficult to calibrate to anything that you can see, and optical size is very difficult to calibrate because people have decided that users are at different distances from the same equipment, and so it's a bit of a challenge. And at the same time, we have to build this knowledge base of typography about its classifications, about the glyphs, and how each glyph is thought of, and each culture is a little bit of a special thing. So there's a lot of work ahead. There are a lot of people working on it. There are a lot of people working on their own with it, and we encourage that. We're sort of dedicated to working on our own as a very fluid group, but then just about everything we're doing is open source. So what Lasse is doing is open source, what Santiago is doing is open source. I do a lot of writing and publishing on the web that's open source, and Dave decides on a lot of open source stuff for us. But then there's other stuff that we're not sure about, so we work on it quietly until we know what it means. And so that's pretty much where we are. That's last year, I think, that we've been working on things, and we're going to start releasing products this year, and you're going to start to see things happening in operating systems this year, and we hope to see things that are going on with CSS as well. And Lasse is going to be talking to people about that as he goes forward. And we also hope to put out some new publications this year that will help to demonstrate this stuff. And we hope that you all enjoy that.
All right.
Thank you.
So someone asking, a couple of people are asking about what the XTRA axis actually is. You know, seeing Lasse's demo, can we see what it looks like precisely? And so there was this website, Variations Guide. I'll put the link into the chat here. This has got the definitions of the axes as they were initially written up and proposed back in early 2017. And so you can see here, this is the sort of full. Hang on a minute. No, this is the YTRA. So sorry, I've mislabeled this. So this is changing the transparent shapes in the Y dimension. So you can see the opaque shapes, the stem and the bar of the H, are not changing. It's the counterforms that are changing inside the letter form. Let me change the screen sharing again.
So basically, while Dave's doing that, I'll just say that there's a list.
Here we go.
There we go. And everything that has a T in the second letter is about transparency. So a full 75% of our axes are devoted to control of white space that typography didn't have control over before for any script. X, Y, various zones of white space being controlled separately from black space without an effect to the black. So there's plenty of concern for both transparencies and opacities in the way we work, and that is applicable to every single script because they all have those things. Any questions there?
Yeah, so there's these fundamental four axes, the X and Y, opaque and transparent. And so the XTRA axis is controlling the white space in the X dimension only. So that makes it very relevant for justification.
And someone's asking how it's different from the width axis. And the width axis has tiny adjustments of the weights so that it doesn't get too crowded. It has significant adjustments to the white space that we call letter spacing in between the characters. And that's a big difference. If you're starting to mix those things with your justification algorithm, the color of the type will start to change if you use the width axis too far. If you use a little bit of the width axis, it probably won't make a difference because it will be below the threshold of the rendering of the screens that you're working on. So XTRA is there to just purely affect white space.
I think this question is slightly different, David, right? So indeed, the grade axis is controlling both the YOPQ and the the XOPQ and the XTRA, at least, right? Because it's not changing the width, but it's changing the apparent color.
It's changing the X and Y opacity.
Mm-hmm.
So when the second letter in our abbreviations is an O, you're dealing with opacity. And so you've got one for X and one for Y. And because when you build fonts of many scripts, those things have to match optically, then those things are also applicable to all scripts, all glyphs of all scripts. The first time that's open to everything to be molded the way people needed to, per optical size, because as we know, the weights of Latin change differently from the weights of Chinese.
And so I think this question is sort of getting at one of the, powerful implications of the parametric axis system, which is that indeed the weight, width, and optical size variations are made by blending together other parametric axes in different proportions.
This is absolutely correct, but it's difficult to leave that blending to users, and the specification does not allow you to record blends in such a way that they can be passed on to users easily. So we must blend everything and give them the axes they need. At some future date, we may be able to give them a pure parametric axis with an overlay of the blends that they can then work with. But right now, the way the technology is set up, it's one or the other. It's very difficult to do something in the registered axes and then go off into the parametric axes, because now you're in a place in the space that is not really on a registered axis anymore, and applications don't really know what to do yet. So things like grade are truly, that's an excellent point. They are a blend of other axes, and that's the way it's going to be until the format is reformed.
All right. So another question about grade: is this something that could be registered? And if so, what scale should the grade axis be using?
There's been a lot of discussion about this, and as I just mentioned, you can use parametric axes or you can use relative axes, is basically the choice that we have. And we started out making grade a parametric axis, but that made it difficult for people to use. So we changed it, and now it is specified as WGHT. So we express the changes in grade as if you were changing the weight axis by the amount that the grade axis says you're changing it. And that's something that we've done for various people who want to be doing this with engineering numbers that they can understand, and that's OS2 values. So we're very flexible on this. The most important thing is that you've got the effect if you need to use it for something, and the value systems people are going to be arguing about for a while. I personally think that everything should have as many value systems as it needs so that the various things can work with it. But again, the way that the format is set up, you can only have one value system per axis.
All right. So what's the effect on file size?
Effect of variables?
Well, I mean, showing what Lasse was demonstrating, right? But using more and more axes, and so there's that sort of promise that variable fonts might offer some kind of compression benefit.
There is certainly a compression benefit to having the standard axes replacing a normal family. As you start to get into parametric axes, if they are extremely useful, like XTRA, I'm very favorable to having them in there. If people can't use them, then we'd rather blend the axes and give them a blended axis for them, because that means that they don't have to carry around extra axes that they can't really use. So there are plenty of plans in the works for subsetting axes and giving people just the functionality they need as we go from projects where we've got like huge files to products. We found that when we make contours much more efficiently with as many composites as we can use and very carefully using the contours, that we can actually cut out about 1/4 of the size of the font just by being smart about the way we make it. And then adding a grade axis is one of the smaller axes. Optical size I think research shows that it's the biggest size-wise, because you've got so many different parameters in motion to make optical size work, that has the most effect on file size. But at the same time, I think that it has the most user benefit, because it means that you can guarantee somebody that wherever they go in the design space, any weight, any width, it's going to work. And that is something that's fairly new. And for WorldScript use, that's going to be, I think, a critical issue.
All right. So actually, there's been a couple of questions in the chat going back to this previous question about grade. So I'd like to speak to that. Basically, yeah, I think grade ought to be a rotated axis. I think we're going to see a lot of type families wanting to use it. And the conclusion that I reached in working with David and other foundries on fonts with a grade axis is that since the grade axis is relative, then it should be on a scale related to the weight axis scale. And so if you imagine you have a range of grade that allows you from your default style to achieve the same visual weight as, say, the 500 weight style, then your grade would be positive plus 100 as its maximum value, so that you can achieve very similar color with grade 100, which is to the 400 plus 100, the 500. And this allows you to get a sense of the balance of the axis, because your grade axis may have, say, only minus 50, right, the equivalent of a 350 negative grade. And the goal is, generally, we can say the goal is to try and make the type consistent across different media. So the classic origin of this that Santiago briefly mentioned is in print media, where you would have, say, a magazine with color pages and black and white pages, for text, the color pages for photography, and some text. And you would want to try and make that text appear evenly. And so because of the different paper, the different inks, different print process, the same digital font would be printed differently. And so you would use this kind of grade adjustment to get the same rendering. And then similarly, when you go from regular mode to dark mode, the way that the light coming out of the screen works is going to change the appearance of the letters, even though they're normally the same. And so the idea is that you're trying to match it, but you may not be thinking about things in terms of percentages. You're trying to match a kind of weight. So if your weight isn't regular, if you're trying to match the weight 700, it's going to be slightly different. But generally, you're going to be matching that regular, and so that's why I think that ranging it off of the weight axis makes the most sense.
Yeah, I would like to add something that you mentioned. That actually was a problem that we have when I was designing newspaper. Well, they have print, they have website, application, iPad. So the type we selected for the text, it looks bolder in web, and on the application it looks lighter, and on paper it's a mess. So we have to, for the brands, it would be great to have unity of all the brand image through all the products. And with grading, that helped a lot to solving those problems.
Yeah. So this is, ideally, you would be able to make the grade relative to wherever you are in the design space. But the way the technology works is not possible. So making it relative to the default is, I think, the best that we can get, since that's going to be, sort of a typical style. Okay, so the next question was about how variation is enabling inclusive typography, and what other scripts have been developed with the parametric system. So we just have a few minutes, so I'll answer this quickly. So the idea of the variation technology enable inclusive typography is this idea that we can match into script typography more harmoniously with this kind of fine tuning, this finessing using the parametric axes. And in the same way that Lasse was talking about the glyph synthesis for a superscript Latin type, in the same way we can see that kind of synthesis being applied to other scripts. And so what other scripts have been using the parametric system? David has produced a couple of demos with some Chinese characters a few years ago. And we are continuing to invite anyone working with other scripts to experiment with this approach that we think is very powerful.
And I leave it up to them to publicize that, because I leave it up to them to publicize. There are
the biggest one would be the faux foundry applying parametric axes to Greek type, which was presented at ATypI 2018. That's fauxfoundry.com. I can put the link into the chat. Okay, and so then final question for David and Santiago about how the parametric axes are drawn, which are made by hand, which are the result of the interpolation, and is a way to automate the branding of the parametric axes.
It's a combination, and it depends on your design. If you start out really thinking far about where you want to go with the design and how far each parameter is going to go, is the way I started out with Amstelvar, and I started out differently with Roberto Flex, and we're still experimenting with different ways of doing things. But clearly, blending axes is possible. Interpolating, extrapolating, parts of glyph repertoires can be treated one way and parts another, and it's a real challenge, but it's also very exciting when you do a bunch of things that are parametrically inclined, and then you blend them and they come right into the places where you want them to make styles work. It doesn't always work that way. The farther you go in a design space, the more likely you're going to be doing some hand work. And if you like drawing, then you go farther. And I like drawing, so I tend to go really far in all of the directions. And then I blend things and a disaster occurs, and then I fix the disaster and analyze the disaster and figure out how to fix the blends or not. Sometimes it's just better to go into the lightest, narrowest, most condensed, largest size and draw it, because that's the best way to get there. So I don't really say that there's only one option.
All right, I think we've got to call it because the next talk's starting. So thanks everyone for attending.
Yes, thank you so much for this talk. And I want to invite all the attendees to go to the Hangout space, and also Santiago, David, Lasse, and Dave. That would be really nice. So I see you there. Thank you so much.